Lesson 9C, Energy, the ability to do work. Gravitational potential energy,
denoted with the symbol E sub P or uppercase U,
is the stored energy found in an object as a result of work being done to it as it raises to a height. An example of this would be the pulling of a roller coaster car to the top of the first hill. As a result of the work done by the motor, the roller coaster cars have displaced up a height. The work done by the motor is now stored in the cars, which will allow for them to fall down in the future. Let's look at how to calculate stored energy when a mass m is lifted a distance of height d. Here's the mass resting on the ground. Fg equals mg. To successfully lift the mass, a minimum magnitude of force equal to mg must be applied to overcome the gravity. Here's the applied force. And the mass now displaces upwards to a height of h. Work from the applied force equals force applied times d. Force applied to overcome gravity is mg, and distance is actually height h. Subbing in, we get work applied equals m times g times h. As we lift the mass, the work done to the mass becomes stored in the mass as gravitational potential energy, E sub P or U. Potential energy, therefore, is mgh, where E sub P is stored energy, m is mass in kgs, g is gravitational field strength, and h is the height in meters. Kinetic energy, given the symbol E sub k or simply uppercase K, is the stored energy in a moving object where acceleration is occurring. We can use the roller coaster example again, but this time as it accelerates down the hill. Here we have the potential energy converting into kinetic energy. This kinetic energy, the energy of motion, allows for the roller coaster cars to return back up the next hill. Let's look at how to calculate the energy required to accelerate an object from rest to a velocity v. We will ignore friction in this example. Work applied equals force applied times distance. This is our work equation. Recall force can be written as mass times acceleration, so subbing in ma, we get work applied equals mass times acceleration times displacement. Remembering back to our kinematic equations, we can sub acceleration with delta d divided by time, and displacement can be replaced with average velocity times time. Manipulating the equation, we'll factor out the 1/2 and the divide by t. We now have work applied equals mass times 1/2 delta v times vi plus vf times t over t. Since initial v is 0 and t divided by t is 1, we get work applied equals mass times 1/2 times vf times 1. Work applied is 1/2 mass times v final times v final. This makes 1/2 mass times v final squared. If work applied is the energy used to accelerate the object, then kinetic energy equals work applied. This makes kinetic energy equal to 1/2 mv squared. Mechanical energy, written as E sub mechanical, is the energy that an object acquires when work has been done to it. This energy is due to its position or its height, its motion, or both. It is the sum of both the object's kinetic and potential energy, which it can now be used to do work itself. The formula is potential energy plus kinetic energy, or U plus K.